All right, ladies and gentlemen, welcome back to 5 Minutes of Math. And I'm going to tell you, this is Mr. Lunsford. This one is going to take about 8 minutes. All right. And I'll tell you why. This set of problems involves geometry, and it involves geometry as we determine the length of certain sides. We're going to set some things equal to each other. We're going to cancel out some variables and like terms. And the most important part is we're going to derive those equations from our shapes. So that's the part that I really want you all to focus on, because they love these problems. Every standardized test I've seen, they involve at least one like this. This is for Tuesday, December 5th. Here are our shapes: x plus 4, x plus 2, and x plus 5. Now, if you notice, in that triangle, those are the lengths of our three sides. So what we have to do is add the x's from x plus 4, x plus 2, and x plus 5. That gives us 3x. Then we add the 4, the 2, and the 5. And that will give us 3x plus 11. All right, that's 6 plus 5 is 11. 3x plus 11. Now, we're going to set that equation equal to what we get from our rectangle. Our rectangle has x plus 3 at the bottom, and because that bottom side is the same length as the top, there's our other x plus 3. Now, if you look at the right-hand side, it says x plus 1. Well, that's the same length as the other side, another x plus 1. So we end up having to add all four sides together. All right? So this is what we're doing. X plus 3 plus x plus 3 plus x plus 1 plus x plus 1. All right, so we put our four x's together, and of course that's just 4x. And then we're going to add our 3, and our 1, and our 1 together. So you see in that yellow box, there's our 4x. That's where that's coming from. But the other side is going to be 8. So of course, that side of the equation is going to be 4x plus 8. So our total equation here is 3x plus 11 equals 4x plus 8. Now we have to solve it. So here we go. We have 3x plus 11 equals 4x plus 8. Now our constant terms here are 11 and 8. And our variable terms here are 3x and 4x. All right, moving on. We're going to move that 11 to the right-hand side of the equation. So let's subtract 11 from both sides. The 11s on the left cancel out. Then we have 8 minus 11. So what we're left with is 3x equals 4x minus 3. All my constants are now on the right. The only constant we have in there is negative 3. However, to solve this thing, we got to get our variables on the other side. So we're going to subtract 4x from both sides, because we're going to take it away from the right-hand side, but put it on the left-hand side. So 3x minus 4x is negative x equals negative 3. All my variables on the left. And remember that negative x is the same thing as saying negative 1 times x equals negative 3. That's the purple part right there. So the last step is to divide by negative 1, and x equals 3. All right, so that's the solution for the first one. Let's move on to the second set of shapes. So here we have a triangle with x plus 7, x plus 10, and 6x plus 9. We're going to add those sides together. So there's our 6x plus 9. There's our x plus 7. And the last thing we add is x plus 10. So let's combine our terms. We're going to combine all our x's. That's 6x plus 1x plus 1x. That's going to give us 8x. And then we have 9, 7, and 10. And that's going to give us 8x plus 26. And that 26 comes from 9 plus 7, which is 16, and 16 plus 10, which is 26. Now we're setting that equal to a pentagon. Now, if you know your rules for geometry, every side on a pentagon is the same length. The problem gives you 12x for all the sides, but it doesn't tell you that we have to add them all up. So it's 12x plus 12x. Here's another 12x. And here's another 12x. DJ Khaled would like this one, another one. So this is another 12x down here. So if you add up 12 5 times, you end up with 60x. Now, if you really wanted to get fancy about it, you could apply the distributive property here and just go 5 times 12x, or just multiply 5 times 12x equals 60x. Now we got to solve it. So here we go. This one's a slightly shorter problem. So we have 60x equals 8x plus 26. That's the beginning of our problem. We set our pentagon equal to our triangle. The only thing we have here are our variable terms, and we only have one constant term. That's going to make it a little bit easier. So let's subtract 8x from both sides, and that'll put all our variables on the left. 52x equals 26. All our variables are now on the left. All we're doing now is dividing by 52. And I will tell you that a lot of times our students will look at that and go, is 52 divided by 26? No, check your math. X is 0.5, and that's the right answer. Okay? Just because you do get a decimal doesn't mean you're automatically wrong. So, going on to this one. No shapes here, but we do have constants and variables on both sides of the equation. This is 8.5x minus 4.3 equals 3.3x plus 3.5. So negative 4.3 and positive 3.5 are our constants. 8.5x and 3.3x are our variables. So let's add 4.3 to both sides. That's going to cancel out our 4.3s on the left. We're going to add it to the right. 8.5x equals 3.3x plus 7.8. And we get over here, we are going to subtract 3.3x from both sides. That's what we're doing in our green. The 3.3s cancel out, and we end up with 5.2x equals 7.8. Divide by 5.2, x is 1.5. All right. And we're going on to number 29. Here we have 9.7x plus 8.2 equals 5.9x minus 7. So our constant terms here are 8.2 and negative 7. And we're going on here 9.7x and 5.9x. Those are our variable terms. All right, so first thing, combine all our like terms. We are going to move that 7 to the left-hand side by adding 7 to the right-hand side. That's a zero pair. Negative 7 and 7 cancel out. So now we have 9.7x plus 15.2 equals 5.9x. Now, subtracting 9.7x will put that variable on the other side. All right, so our constants are on the left. Our variables are on the right. 15.2 equals negative 3.8x. Divide by negative 3.8. Watch your signs. X is negative 4. Thank you so much for listening, and I will talk to you again in about 24 hours. Thank you for hanging in there.